Hello, Matt G for IYT here. Today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 27, which reads, it is often found that adding a preamplifier to a H or an HF receiver has little effect on the signal to noise ratio of weak signals. Why might this be so? A, the extra gain will reduce the overload margin, so intermodulation effect will mask any improvement. B, natural HF noise is relatively high, and antenna-sighted preamplifier will have little or no effect on the received SNR, or signal to noise ratio. B, preamps are wideband devices, so will pick up a wider range of noise, which will reduce the overall noise performance. Or D, HF amplifiers are inherently noisy, so a preamp is unlikely to be any better than the receiver it is to be used with. So this is a bit of a tricky question. I always find this one hard to answer, but there are a couple of answers we can rule out straight away. So first of all, the extra gain will reduce the overload margin, so intermodulation effect will mask any improvement. So what this is getting at really, if we think about the dynamic range of a receiver, it's the difference between the quietest thing that we can hear at the bottom here and the loudest thing that we can hear before it starts to get distorted. So this point here is our overload point, and this point here is the quietest thing that you can hear. So you've got the gap between them is called your dynamic range. Well, if we add an amplifier into this system, we are effectively raising the quietest thing that we will ever hear. So the quietest thing we'll ever hear now gets moved up maybe by 10 dB. However, we're not doing anything to move up the loudest things that we can hear without distortion. So really what's happening is our dynamic range is getting smaller as a result of adding this preamp. Now realistically, you'd add the preamp in, you'd aim to operate the radio within its dynamic range rather than deliberately moving the noise floor up so high that everything's going to become distorted. So no, this won't necessarily reduce the overload margin automatically, but it is possible that that dynamic range is reduced. So let's rule that one out straight away. The other answer I think we can rule out fairly quickly is HF amplifiers are inherently noisy, so a preamp is unlikely to be any better than the receiver is to be used with. So I think there is some credence to this second part, that not necessarily that it's going to be unlikely, but that you do really want a preamp that's going to be, it's got to have to be a really good preamp to add anything to your system. But I don't think that HF amplifiers are inherently noisy, so we can rule that one out as well. So we're left with these two answers. B, natural HF noise is relatively high, an antenna-sighted preamplifier will have little or no effect on the received SNR. And yeah, this answer is thinking about the SNR. This is exactly what we are being asked about here, is the signal-to-noise ratio. And C, preamps are wideband devices, so will pick up a wider range of noise, which will reduce the overall noise performance. And yes, it's true that preamps can be wideband devices, but the wider range of noise, you would hope maybe that your radio is selective enough maybe to get rid of some of that. But I'm going to flip over to the full license manual, because there's a few good diagrams here that are worth familiarizing yourself with, because they do really explain the answer to this question. So we see here we've got this poor receiver, and we can see that at the input to this receiver we've got 2 picowatts of RF signal and 0.02 picowatts of RF noise, and the 2 is 100 times greater than the 0.02, so we say our signal to noise ratio is 20 dB, and as it happens, this receiver is very noisy, so it receives the 2 picowatts of RF signal and it receives the 0.02 picowatts of RF noise, but it adds its own half a picowatt of RF noise, of receiver noise, and so the overall signal to noise ratio with this receiver is 5.8 decibels. Now if we look at a scenario where we put a preamp in line with this, we see we have our 2 and 0.02 RF signal and noise, the same signal to noise ratio of 20 decibels. The preamp, just like the radio is doing, is going to add its own level of noise, but in this case is adding significantly less noise to that signal, and we're only seeing an extra 0.1 picowatts being added here, and so our signal to noise ratio coming out of the preamp is 18.2 decibels. However, our RF signal and our RF noise, but mainly our RF signal, is a lot stronger going into the receiver, and this is helping bring it above that receiver noise. So when we calculate the overall signal to noise ratio with the additional receiver noise with that preamp in line, we see that it actually has come up to 14 decibels. So it's quite a decent improvement over the original 5.8 decibels we're seeing over here. So that's with a poor receiver. What happens if we put a preamp in line with a good receiver? And we can see again we're seeing 2 picowatts of power, 0.02 picowatts of noise for a signal to noise ratio on the input of 20 dB. We then amplify with this preamplifier by 10 dB our RF signal, our noise, and it introduces its own 0.1 picowatts, and we get 18.2 dB. Now, what we also we don't have here, and I think this might be a mistake in this diagram, you have to work out the numbers for this, but the signal to noise ratio for this receiver, based on these figures, so based on the 2 and 0.02 and the receiver noise of 0.01 picowatts, comes out at 18.3 dB overall. For the signal to noise ratio. However, when we put the preamp in line and we add in that additional preamp noise, that preamp noise is much greater than what's being added by the receiver, and we actually see our overall signal to noise ratio come down slightly to 18 dB. So what we're seeing here is that when we add in this preamplifier, we're actually seeing that there's no real effect on the signal to noise ratio. Certainly it won't be perceived. That 0.3 of a decibel is absolutely nothing. It's not going to make a difference. But we have had to add in this preamp and presumably pay for that, and it's more complexity in the system. So where you've got a good receiver, or specifically where the receiver noise is significantly lower than the preamp noise, it's not going to make a difference. On the other hand, if you've got quite a poor receiver, quite a noisy receiver, it does make a difference. So this is really an area where there are a lot of pitfalls, and you have to kind of run the numbers and fully understand the devices you're working with. Fortunately, we're only dealing with it in a theoretical sense, so we need to arrive at the answer that the full license exam is looking for. And it's the answer, I don't think it's worded particularly well, but the answer that it's looking for is in fact B. Natural HF noise is relatively high, and antenna-sighted preamplifier will have little to no effect on the received SNR. I don't think this quite matched up to the question. This is not one of the best questions, but it's little to no effect on the received SNR is what we're looking for. So yeah, let's skip down to the answers and see if we've got that one right. And we can see, of course, the answer is B. Bit of a tricky question, that one. It's definitely worth familiarising yourself with these diagrams and the maths that goes into them to fully understand the answer to that question. But for now, thank you very much. I'll catch you for the next one.